Hey everybody, today I'm going to show you how to make a box plot. And what you have to know is that there are 5 key points that go into a box plot. The first one is the minimum, the second one is the maximum, and the third one is the median. Those 3 things you are probably very familiar with. The other 2 points that you might not have known about before are called the upper and lower quartiles. The prefix of the word quartile is the word quarts, which is telling you that the box plot is going to be divided into fourths. So the upper quartile represents 1/4 of the data, as you will see when we graph our first example. The lower quartile will also represent 1/4 of the data. But let's just get to it so you can see how this is done. So here's our example. Make a box plot for this set of data. Be sure to mark the 5 key points. And as you can see, here is our data. The first thing that you do is you order the data from least to greatest. So let's do that right now. The lowest number up here is 9. The next lowest is 10. So on and so forth. Alright, so now that we have the data in order from least to greatest, the next thing we have to do is start to separate it into our quartiles. We are going to identify these 5 points, with these 2 being the most important ones that we find in the beginning. Well, the minimum is pretty obvious. It is 9. The maximum is also obvious. It is 25. The median is the middle term. And you can do that with many methods, but here's how I'm going to do it. I will just cross off the lowest and highest number until I get to the middle. Now we have crossed off 4 numbers on each side. And if I go ahead and cross off 14 and 16, well, there's no number left in the middle. If this happens, you take the 2 numbers that you are left with and you find the middle of where they are. This is a 14 and a 16. If you take 14 and you add 16 to it and you divide it by 2, you will be taking the average of those 2 points. And the average of any 2 points is going to give you the middle in between them. 14 plus 16 is 30. 30 divided by 2 is 15. So the median is 15, which is right here in the middle. So we now have 3 of our points already found, and the last 2 that we have to find are the lower and upper quartiles. Here's how you do that. Since the median splits the data into 2 halves, we now have 1/2 of the data on this side, and then 1/2 of the data on this side. And when I say side, I'm talking about this line right here. Half the data is over here, half the data is over here. Well, we're trying to split our data into 4 pieces. So the way you would do that, well, we already have a half. What is half of a half? 1/4. We are going to take this data and find the median of it a second time. Cross off the highest number and the lowest number. The highest number, the lowest number. The middle of the lower half of the data right here is the number 12. I'm going to put a line through it, and I'm just going to put Q1, which represents the lower quartile. Over here, we now have to find the middle of the upper half of the data. We have the number 20. I'm going to call this Q3 because it is the 3rd quartile. I'm just going to clean up the work a little bit. And let's get all these lines out of here. So what we have now are the 5 key points that we needed. The minimum, the maximum, the median, the lower quartile, and the upper quartile. Again, this data is being split into fourths. Notice how we have 1, 2, 3, 4 gaps in our data. The first fourth of the data is right here. The second fourth is right here. The third fourth, and then the last fourth. What we are now ready to do is make our box plot using this information. Well, draw a number line, and then start by placing your minimum and maximum values. This number line has already been set up so that the minimum is all the way over here at 9 and the maximum is a perfect distance from it at 25. In most cases, you would probably draw your own number line and you would have more than enough of these markings, and you would probably have to guess a little bit of where to put these. But in any case, put the minimum, put the maximum down first. Well, let's fill in the rest. Now it is time to place our other points. Well, we have the minimum right here at 9. We already have the maximum at 25. Our median is at 15, which is right here. I'm just going to go ahead and clean this up a little bit more. There we go. The lower quartile is at 12. And the upper quartile is at 20. Here's how you make the final part to the box plot. You now have to make the box. The box is formed by taking the lower and upper quartiles, and those make the endpoints of the box. Let's see. Let's fit a little bit better. The next part you have to do is connect the dots on the end. And there you go, and here you go. The last line you need to put in is right here in the middle. And it's the median. On a typical box plot, you will always see a line right here, and that line is representing the median, the middle of the data. This is your box plot, and that is all you have to do. So the last thing I want to discuss with you is why box plots are useful. And what they basically do is show you how the values in the data set are distributed. So I'm showing you 3 examples here, and they go with these 3 situations. Let's just talk about this for a moment and think about it for a second. Situation A, there's the box plot, and here's the situation that goes with it. The ages of students in an 8th grade class. Well, most students in an 8th grade class are going to be anywhere from 12, 13, 14, maybe 15 years old. All of those ages are really close together because, well, all the numbers are really close together. That means if all of the kids in the class are one of these ages, all of your data points are going to be really close together. So the box is going to be small, and then all of the outer parts, the maximum and the minimum, will also be relatively small. Right here, the second situation, the heights of students in an 8th grade class. This could be a little different. Heights could be anything. You could have a kid in the class who is really, really short. You could have a kid in the class who is ridiculously tall, like a future basketball player. And then you have all the kids who are an average height. That's when you could see a very small box, but then the minimum and the maximum are very far apart. Lastly, when would you have a really, really big box? Well, that would mean when all of the data points are really, really spread out, making the box really huge. If you were to randomly ask people on the street how old they are, you might get a box plot that looks like this. If you're just walking around on the street, you might come across somebody who is in their 40s, their 50s. Maybe you'll see a kid who is in their 20s or in their teen years. You're going to get a really far spread of data points, which will make the box really, really wide. The last thing for you to do is a couple practice problems. So what you should do right now is pause the video, read this, try to figure it out, and then resume the video and I will explain things. The first thing up here is the interquartile range. that is just asking you how wide is the box. And right here we have the point labeled Q1, and right here we have the point Q3. Q1 is at 70, and Q3 is at 150. Well, the interquartile range is where you take the maximum, or the quartile 3, sorry, I should say the third quartile, and you subtract the smaller quartile, Q1. Q3 was 150, Q1 was 70. 150 minus 70 is 80. So the interquartile range is 80. The median is just the middle, that is 100. Find the number below which 75% of the data falls. That is also very simple. Remember, the word quartile has a prefix, quart, meaning 1/4. 1/4 of your data is below the box. 1/4 of your data is above the box. 1/4 of your data is the lower part of the box, and then the other 1/4 is the upper part of the box. So 1/4 also means 25%. So all of these are really 25%, and it says what number below which 75% of the data falls. Well, 25, 50, 75, the answer is 150. Last example. Go ahead and pause the video, read the situation. You are basically just making a box plot based on this data, so do that on your own and then resume and you will see all of the answers. Here we go. Hope you got this right. Well, that does it for the box plot. Hope you learned something from it. Watch this video as many times as you need to. See you guys later.